Imagine you're hiring for a job. 100 candidates walk in, one at a time. You interview each one, and right then you have to decide. Hire this person or pass. You cannot go back. Once you say no, they're gone forever. And you have no idea how good the next candidate will be. So how do you find the best one? This is the secretary problem. And it has a surprisingly clean answer. Let me set it up properly. You have n candidates arriving in a random order. After each interview, you must decide immediately whether to hire or reject. No callbacks. No second chances. Your goal is to pick the single best candidate. Not just a good one. The best. Most people's first instinct is to just pick whoever seems good early on. But that's a trap. You have nothing to compare them to. The first person might be amazing, or they might be mediocre. You just don't know yet. So some people flip to the other extreme. Wait until the very end, then take whoever's left. But that's even worse. The best candidate probably showed up somewhere in the middle. By the time you get to the last person, the best one is long gone. Both strategies fail. So what actually works? Here's the insight. You need a sample first. A calibration phase. Interview some candidates without hiring any of them. Just observe. Build a baseline for what good looks like. Then, after the calibration phase ends, hire the very next candidate who beats everyone you've seen so far. This is called the threshold strategy. But the question is, how long should the calibration phase be? Too short, and your baseline is worthless. Too long, and the best candidates have already passed. The answer is 1/e. About 37%. If you have 100 candidates, observe the first 37 without hiring anyone. Note the best among them. That's your benchmark. Then hire the first person after that who beats the benchmark. If nobody beats it, you're stuck with the last candidate. This gives you roughly a 37% chance of picking the absolute best candidate. Which sounds low, but think about it. With 100 people in a random order, the odds of randomly picking the best one are 1 in 100. This strategy multiplies that by 37. Now here's why 37% specifically. Suppose the best candidate is at position K, where K is greater than R, your cutoff. You hire them if nobody between positions R and K-1 beats the best person from the first R. That probability is R divided by K-1. Sum this over all possible positions for K, divide by N, and take the limit as N grows large. You get an integral that evaluates to 1/e. The optimal cutoff is exactly 1/e of your candidates. What's strange is this result doesn't depend on N at all. Whether you have 10 candidates or 10 million, you always skip the first 37%. The scale disappears, and you're left with just E, that same constant from compound interest and natural logarithms. The secretary problem shows up everywhere you make irreversible decisions under uncertainty. Apartment hunting. Selling a house. Choosing when to stop looking for a partner. Whenever you're searching through options you can only see once, in sequence, this logic applies. The math doesn't tell you what to do with your life. But it does tell you this. Explore first, then commit. Spend about a third of your search just learning what good looks like. Then hire the first one that beats everything you've seen. It won't always work. Sometimes the best candidate walks in first. But on average, across all possible orderings, it's the best strategy you have. That's the secretary problem. A hiring puzzle that turns into a theory of when to stop searching. And the answer is never 0, never forever. It's 37%.